What is going on, everybody? Welcome back to the Blackboard, and we are going to work on our last set of examples for this chapter, and it's going to be covering orthogonal, orthonormal bases, and the Gram-Schmidt process. But before we actually do all of that, we're just going to take it step by step. And so for this example, we're going to check if the given vectors are orthogonal or orthonormal or neither. And the simple way to do that is, if you recall from lecture, orthogonal means that their dot product is equal to 0, and orthonormal is not only their dot product is equal to 0, but they each vector is a unit vector, and if it's neither of those, then it's neither of those. So let's get started. So the first one, we are given vectors 2, -4, and then 2, 1. And if we were to take their dot product, so 2, -4 dotted into 2, 1, we see that we will get 2 times 2 is 4, -4 times 1 is -4, which is 0. And now to check if they are, orthonormal, because we know it's orthogonal since their dot product is 0, we're just going to take one of the vectors and then find their magnitude. If it's equal to 1, then we have to check the other one. If it's not, then we can just automatically assume that it's orthogonal. And so the first one, its magnitude will be instead of the parentheses, it'll be 2 squared plus -4 squared, and that already there is kind of like, red flags. We have 4 plus 16, which is 20, and that is not equal to 1, so that means the set is orthogonal. Alright, so the next one, it's pretty much the same thing. We're just going to take their dot product. And the good thing about this one is that we have 0, so all we have to do is just multiply -4 and 5, which will give us -20. And right then and there, it's not equal to 0, so this can't be orthogonal. Neither can it be orthonormal. So the set is, it's neither one of those. For C, again, same thing. Just gonna take their dot product, dotted into -4/5, 3/5, and that's gonna be equal to -12/5. Plus 12/5, and that's gonna be 0. So now to check their if they're orthonormal, we will just simply take their magnitude. And so the first one is going to be 9/25 plus, not 4, 16/25 under square root, and that is going to be equal to 25/25, or 1. So that is that is a unit vector, and the other one is going to be the same thing, 9/25 over 16/25, because we're squaring it, so the negative becomes a positive, and that will also equal to 1. So this is both, no, this is not both. This is an orthonormal set. So now we are down to our last two. And so the first one, kind of like same old, take their dot product. And so when you take their dot product, you'll see that 2 and 4 is equal to 8. -5 and -2 become a positive 10. And then 6 and 3 is equal to, 6 and 3 would equal to, wait, time out. 18, and we know that's not going to be equal to 0. So what is this going to 36? So this is neither of them. And then for our last example is I'm just gonna name this V1. Actually, let me change the color. V1, V2, V3. That is a terrible 3. V3. And so V1 dotted with V2, we will get that this is equal to 0. V1 dotted with V3, that will be giving us negative root 2 over 4 plus root 2 over 4. So that will be 0. And then finally, V2 dotted with V3 will give us the same thing again, 0. So it'll be giving us root 2 over 2 root 2 over 4 minus root 2 over 4, so that'll be 0. And so we know that this is orthogonal. So now we got to check if each vector is a unit vector. So for V1, we will see that this will give us 2/4 plus 2/4, which is just equal to 1. So their square root is just 1. V2 will be, it would be the same thing because we have root 2 over 2. And then V3, whoops. V3 will be the square root of 1/4 plus 1/4 plus 1/4 plus another 1/4, all under a square root, and that would just give us 1. So these are all orthogonal, and they all have a unit vector of 1, so that means this is an orthonormal set. And yeah, that pretty much concludes this first example. These are like relatively simple. I mean, all you have to do is just check their dot product and find their magnitude. The only thing that you really need to be careful on is like the difference between orthogonal and orthonormal. For some reason, the first 5 letters are the exact same thing. So, keep your eyes on that. So now let's move on to our second example. So this one's telling us to find the coordinates of x relative to the orthonormal base of b in R of n. And so for our first example, we are given 2 points, and our x was 1, 2. And so to find these coordinates, you simply have to take the dot product and then multiply by each vector in the set. So the first one, which would be x dotted with b1, we're just gonna name this b1 and name this one b2. And so this will simply just be 1, 2 dotted with negative 2 root 13 over 13 and 3 root 13 over 13. And so that will simply give us negative 2 root 13 over 13. And then 2 times 3 is 6 root 13 over 13. And then for the next one is the same thing. It's just the second vector. So x dotted with b2. And so that would just be equal to 1, 2. It's pretty much the same thing. It's just the x and y for b2 are flipped. So this will simply be 3 root 13 over... Whoops, I messed up. I forgot, I'm taking their dot product. Nah. There you go. So our first coordinate is negative 2 plus 6, and so this would be 6 minus 2 is 4 root 13 over 13. My bad, because it's our dot product, so it should be a scalar. So now the other point is the same thing, but instead of b1, you're dotting it with b2. And so they are flipped, so we have 1 times 3 root 13 over 13. So we should simply have 3 root 13 over 13. And then 2 times 2, it is 4 root 13 over 13, which is just 3 plus 4, which is 7 root 13 over 13. And so our coordinate will just be 4 root 13 over 13, and then 7 root 13 over 13. And so that is our answer. And so now we can move on to the next one, and it's pretty much the same thing. We're just going to take their dot product, and that will give us our each point. So our first one is just going to be x dotted with b1. And so as we can see is we have 5 times 3, which is 15 over 5. So that is just 3 plus 10 times 4, which is 40, divided by 5 is 8. And then we have 0. So this would just be 3 plus 8, which is equal to 11. The next one will be the second vector, and this would be 5 times negative 4 over 5. It should be negative 4. And then the other one will be 30 over 5, which is just 6. So we have 6 minus 4, and that will just give us 2. And then lastly, the third one is just 0, 0, and then just 15. So our coordinate relative to the orthonormal base is just simply 11, 2, and 15. And it has to be in the order that it was provided, because each one would be like respect to that vector. And so that's pretty much it for this one. These are relatively simple. And that is it for the second example. And this also concludes this video. Again, to find whether something's orthogonal or orthonormal, you check their dot product. If it's 0, then you check if they're a unit vector, then that means they're orthonormal. If their unit vector is not 0, then it's orthogonal. And then for this one, you just take the coordinate that they give you, and then take the dot product of each vector in the basis set that they give you, and then now it should be your answer. So again, thank you guys for watching, and I'll see you in the next video.